All right. Well, thanks everybody for joining. I thought we would start off with Patrick and Chance talking about the process that they took to build the threat profile around VOLTTRON deployment on the campus, and use that as kind of a kicking off point for
Jackson, do you want this?
Oh, sorry. Who's and use that as a jumping off point for talking about use cases that the rest of you are using VOLTTRON for. Just, there's VOLTTRON's very flexible, can be deployed in a bunch of different ways, so it's important for us to understand how it's actually being used. So with that, I'll turn it over to Chance and Patrick to give an overview of the threat profile that we did for the campus.
Okay, thank you, Jeremy. Yeah, the threat profile that has been sent out to everybody contains several different things, and it starts with kind of an introduction there of the process that I've been through a little bit, so I just want to touch on it a little bit, where we do threat-based software analysis or secure software development. That sort of covers the entire life cycle of a development process. With the VOLTTRON team, we focused mostly on threat-based software analysis, a little bit on code review in the secure software development area. And I will go ahead and share. Let's see. There we go. Is everybody seeing the document that I'm now sharing?
Yep.
We see it.
Okay, good. So we focused on threat-based software analysis, and that's what this threat profile document we're looking at is. And basically, we wanted to determine the threats, prioritize them, and then find attack paths and mitigations. And there's a table down below that's kind of the final result, and I'll just quickly go through that and turn it over to Patrick. But here you see this table too, where we show the assets, the threat type, denial of service, repudiation coming from the STRIDE model, the priority of that threat based on the CIA model, confidentiality, integrity, and availability, resultant conditions, what can happen if that kind of threat actually gets in and causes a compromise, and then these last two columns are the main parts of the threat profile. How does an attacker get in? And then this last column, what can we actually do about it? And so you'll see there are several things that we've come up with when we did this analysis. The things that are in bold are things that the VOLTTRON team can go and work on and fix. The things that are not in bold are things that have already been done. So the mitigations were already in place, but now we have them documented. So this is our final product. And then the last thing I'll say about it before turning it over to Patrick. When Jeremy says use case, the way our team interprets that is we interpret a use case to be this diagram. And I'll let Patrick go over the diagram. They are basically what we want to start with when we're doing a threat profile or doing any of the secure software development. We want to start by obtaining a diagram, usually working with the team to come up with this initial diagram. And once we have that, that pretty much defines, in the case of VOLTTRON, that defines the VOLTTRON deployment use case. The one we've got here is the VOLTTRON campus deployment. And I'll let Patrick kind of go through the diagram and any of the other process. And then the idea is we'll sit back and listen to what other use cases are out there and how we might want to address them if you guys want to, kind of a thing. So go ahead, Patrick.
So you guys can see right now the level of abstraction we have for this essentially a data flow diagram. This is what we use to generate those resultant conditions that are in this table using a tool provided by Microsoft. It's actually Microsoft's internal tool. These here are generated from the Microsoft threat modeling tool with a whole lot of other duplicates and false positives, which we have to spend time going through and distilling down into this list and matching it with actual assets we want to protect. In this campus deployment, you can see that these red dotted lines are the trust barriers. So for this particular case, we went by just machine. So this level of trust is a machine, and then this one is a campus. In this particular case, PNNL campus. And then we have the interactions between agents and the platform and databases and browsers and users. And all of this goes into that tool, generates a whole bunch of result conditions, things that could happen at a pretty high level. We distill that down into the deduplicated ones that really matter. And as Chance went over, we categorize those, prioritize those, and then we work with the developers, so the VOLTTRON team, to figure out, okay, now that we have a result condition, what are the possible attack vectors to get to that condition, that bad state? And that's really where the majority of the work comes into creating this profile. And then once we have those attack vectors, again, what are the controls at the end to mitigate those, whether or not they already exist? So at the end, we have a list of controls, some of them already done, some of them that need to be done. They can be mapped all the way back through a data flow diagram in a particular use case. So as we think about other use cases you guys have, it really would just be a sort of a change to this diagram for a different use case and rerunning through a lot of the same type of processes that we've already done. I imagine there would be a lot of similar result conditions and attack vectors as this particular use case. So pretty much a quick high level, that's the process we went through. I don't think it was too painful. Craig can back me up on that one.
Nope, that was process was pretty.
Yep,
painless.
the process wasn't too bad.
So one thing to take note of on the diagram are the circles represent pieces of the software, typically agents, and the green boxes represent the interaction. So if you look closely, maybe we can zoom that up a little bit. So we have the VOLTTRON platform, the VOLTTRON, the actuator, and then the various agents and how they interact with the platform, and then how those interactions leave the campus VOLTTRON collector over to the VOLTTRON central. Those numbers represent.
The numbers are just labels of the interactions so that we can track the interactions throughout the result conditions in the table. Again, so that we can see where the controls come from. So we see here, we've numbered. So for this result condition, this exists on all the interactions 1 through 5, 8 through 16, 19 through 23, right? This exists, this particular result condition exists in several places in that diagram. So it's a way to track all the way through result conditions to vectors to controls, all the way back to the diagram. And that's why we've labeled the diagram interactions.
So for VOLTTRON, we want this document to be something that the sponsor can see to evaluate security requirements and maybe decide to provide funding to take care of certain mitigations, or at least understand the risk of not doing that. We also can use it as a requirements document back to the VOLTTRON team to say these are the things that can be worked on, those bold things. And then it also just is a documentation of where VOLTTRON stands in terms of the current security posture.
Well, then especially what is of interest to the community to meet their needs, because their needs are going to be different from each other and certainly different from us.
So one piece that I don't see mentioned in here, and I think most of my deployment looks a lot like what you've got here for PNNL. I would say we probably have a little less user interaction at the platform level in each building, or the edge side of things. We keep all that sort of in a completely separate subsystem. But one thing we are concerned about is, in general, when you start looking at commercial buildings or non-lab-based buildings, these networks that we're plugging the platform into to collect data from, typically fairly unsophisticated. So they will have unmanaged switches. They'll have a little, there won't be any security controls. So when you talk about security controls in the network, and then it's just not clear that even that attack vector of something operating on the local network through, say, the master agent or whatever driver technology you're using, I don't see any of that sort of enumerated in here.
Right. So it depends on how we want to scope it. So in your situation, you've got some of these commercial buildings that are.
Well, I mean, let's just talk about it in the context of what you have here. So
right.
In this case, I just don't see anything documenting like some nefarious actor in a building using the interfaces that say the master driver. I don't really see the actual drivers in here,
right.
Which actually are new interfaces to the outside world. The master driver really is all internal to VOLTTRON. It schedules things with other agents that are actually doing the communications externally. So those I would think would represent another attack surface.
Right.
Okay, well, and that kind of comes down to how secure is the VOLTTRON box itself. If they can't get into the VOLTTRON box or send commands through to the drivers, then you're safe. But otherwise, yeah, if they could use those interfaces. But if your network's unsecured, then they could do that sort of thing without VOLTTRON as well. But I guess VOLTTRON provides a more convenient way of doing it. Is that kind of what you're?
Well, I'm just kind of curious as to like there's another attack. There's a different flow. Like that's you're talking about it in terms of actuating a valve at the edge. But what if I'm worried about getting from one building to another building through VOLTTRON, or doing something to my sort of I can't read what you have here, what it's called here, VOLTTRON collaborators, or you've got VOLTTRON Central here. What if anything to sort of prevent any proliferation through that network via VOLTTRON through any. I just there are additional interfaces there. So if it's scoped to be such that you just don't care about those, that's fine too.
Well, maybe. So I think so this use case, this is in a well-controlled network, right? So then I think the next, maybe another one is, okay, let's say that the network's not well secured. So maybe could you talk more about the environment that you're working in? Is it just kind of wide open, or?
Well, I can talk about HVAC networks in general. I don't think it's specific to our environment. In fact, in some of our locations, at least in the city, things are pretty good. And some with the corporate partners that Matt is talking about that we're working with also have pretty good controls. But if you pick any like random 50,000 square foot building that's being managed in a fairly unsophisticated way, say the local controls vendors who are responsible for communications and graphics and HMIs and that sort of stuff, when you walk in there and open up whatever cabinet in that building that the BAS is housed in, you'll find a 5 or 8 port dumb switch that some variety of equipment is plugged into it, including the BAS system. There's generally not any sort of port access control or any of those sorts of things. So it's not necessarily that it's it's just an untrusted network, and you don't really have any visibility into it. So you don't know. And generally, not only is it that there's a dumb switch in that cabinet, but generally every port that's plugged into that going to other mechanical rooms, etc. When you get to that mechanical room, there's another dumb switch that could have any number of devices plugged into it.
Okay.
So it's not a well-controlled network environment is the best description.
Andrew, I've got a question for you. In that not well-controlled environment, you're plunking a VOLTTRON system into it. Do you have the ability to get control, or is that totally out of scope for you?
I mean, it's certainly something we're interested in. Like, I think what we'd like to end up doing is running something like Bro, and maybe not in a full, like, you know, obviously we don't have the control to go intercept. Like, we can't go say, okay, we're going to put a device in between all the other devices on the network and, you know, whatever route out there is, or, you know, some key point. But what we could do is, like, just in promiscuous mode, take samples on a regular basis to flag. It's more of a alerting than an actual, it's an IDS, not really a IPS, but we think there's value there. We think that's actually, in fact, you know, as we talk about, you know, this isn't necessarily the concern of this call, but when we talk about furthering VOLTTRON as a technology, and that there's actually a, you know, when you start talking about introducing a new technology to something like the building automation stack, IT organizations in some of our more sophisticated customers are concerned and want you to, you know, but this could actually be a way for us to deliver value both to the mechanical engineers and mechanical, you know, facilities managers that we're traditionally focused on, but also to the IT organizations that are responsible for these networks.
Right. So while it's there interacting with the building system, could you also use it to secure the environment, or at least notice something bad going on?
Exactly.
And there's been a little research into that. We have a SEDS project where VOLTTRON's being used to basically man in the middle, kind of intercept commands going to devices and send that off to some module for analysis before letting it through or not. And that might be something that we could expand upon for use in here.
Yeah, in our case, like, I'm not even sure that it's required to be a core piece of VOLTTRON. It could be. It could use the message bus to communicate some of that stuff back. But, you know, sort of a early thinking on it was just having something that runs every day or every few hours, samples, you know, a few minutes worth of traffic off the network, uploads it to a central, you know, repository, something like Splunk or whatever, where you run some light analysis on it and start detecting if you see anomalous devices or those sorts of things.
Yeah. Yeah, that would be good. And that's what we've been doing on our campus deployment. We send logs to Splunk just in case. But
so Andrew, this conversation we're having is, at least as far as I'm concerned, is exactly the kind of conversation we wanted to be able to have, to get those use cases that are different than what we've gone through. We worked with Jeremy's team here and came up with this diagram, and this team is pretty top notch when it comes to security. I mean, Jeremy's VOLTTRON development team. And as we went through the diagrams and honed in on the different boxes and circles that we needed, and then started the assessment part and came up with the different threats and the different mitigations, we focused on the environment that we came up with initially. So what seems good to me going forward for your use case, I guess I would ask you, if we were to take this diagram and alter it to reflect the kinds of interactions you've been describing, so that we could then continue through the process of doing the threat-based analysis, would that bring value to finding holes, seeing things you might not have thought of, or at least justifying why you want to do what you want to do? Because that's kind of what came out of the exercise with Jeremy's team, is they were very familiar with what they've been doing security-wise, very familiar with their system, but this diagram hadn't existed, and we found things to fix and to work on. And that's sort of the objective. And I'm wondering how that might apply to your use case.
Yeah, I mean, I think all of this is valuable and good. I think from our perspective, as we start looking at sort of a SaaS platform we want to offer, this is speaking from Ace IoT Solutions, the company that's, my company and who's actually doing this work. We want to be able to point to things like reports from national labs that show threat profiles and what we've done to mitigate them.
Right.
So yeah, I think this is valuable for the ecosystem. It's valuable, while we're not here talking about how to promote VOLTTRON and support its expansion, into new applications or whatever, but this does seem like a key part of that process.
For sure. Yeah. Because if you could show a potential client something like this and say, here's all the potential threats, here's how we're mitigating them, that sort of thing, I think that would help you make the argument, right?
I would love to hear from other folks who are maybe have more familiarity with the campus environment. David, does this pretty well reflect what you would consider your use case at Toledo, or do you think there's some adjustments here, or what do you think?
I think that there's a fair amount of overlap between what we're seeing here and the way that we have ours laid out. A lot of our deployment is on a secured facilities network that's pretty well locked down at a network level, with controls on switches and things like that. And so we've mostly focused security-wise on where it crosses from there onto public networks that we can actually talk to. But the actual layout of it is relatively similar to this. We don't really have the VOLTTRON central components or web server pieces set up for the most part within that. We use Grafana, but that communicates with our database, which itself has a read-only node that's available publicly, but otherwise has all of its writable nodes inside the secure network. It doesn't really go back to VOLTTRON. I don't know if that.
Yeah. Well, and that's a good point too on that. So, and Andrew, your database, that all the data is going up to your cloud, right? And into a database there that's well secured, right?
Right. Yeah. So we use VCP for that functionality for all the transport. None of the edge agents run a historian that talks to the database. They run historians that, the forward historian or forwarder agent that pushes data to the cloud platform.
Okay. Because that was one thing that when we were making this diagram, at first there was some talk about, the security of the database and what we need to worry about there. But for you and David, it seems pretty much, that's taken care of. You're not really concerned with that. You're more concerned with on the customer network.
Yeah, and that's what this kind of shows the same thing, right? Campus A, that's where your actual historian connecting to the SQL database, and the other instance, the historian is connecting through VCP, right?
Yeah. Okay. So Brandon, can you maybe talk about 8 minutes setup?
Yeah, ours, we're basically just running on a single system within a closed network. So it's really a pretty simple setup.
Okay, so yours, okay. And single system, and then just pushing data to AWS, right?
Yeah.
Okay. And then your VOLTTRON nodes, there's no reason for them to talk to each other?
Right. There's just a single VOLTTRON node.
Okay. So that's a pretty simple use case then.
Yeah.
Let's see, SES. Or is your setup similar to the one Andrew was talking about, or do you have a different setup?
Yeah, I would say that it's pretty much the same as what Andrew's talking about.
Okay.
So this is valuable for me just to listen into, to what you guys are talking about, where you're at so far. I don't really have much to add. Dave, perhaps you do.
Hello? Yeah, so pretty much the same situation as Andrew, I think. I think we'd be concerned about the device itself and somebody potentially getting access to the device, maybe dropping down into single user mode, grabbing credentials and things like that off of it, and then coming up through VOLTTRON and gaining access to other buildings, compromising other devices, flooding local networks. So if we had a backnet network and somebody sort of used one of the agents to start flooding it with traffic and bringing down some of the systems in the local building, I think that's sort of where we would be primarily concerned with, what impact that might have.
That case actually came up during our discussions in the development of this threat profile.
Yeah, so that's pretty much it. I think Andrew, kind of covered that a little bit with, that sort of local customer network. And
okay. What's the physical security like for your deployments? Is it, so we're for a separate deployment I'm familiar with. It's basically open office space. Anybody could walk in and have physical access to a box. Is that similar to what you guys have, or is it at least in a closed room that only operations would have access to? Or?
Yeah, so generally it would be in a mechanical room in the bowels, but if somebody knew that was available, they could go undetected quite easily, as oftentimes there aren't a lot of people coming and going. So and they're not like using biometrics for security to get into these spaces either. So oftentimes it's like if you can manage to get on the elevator, go down a couple of floors, you're at the mechanical room. It's not really so much the local network either, because like Andrew said, there's not a lot of sophistication there. So if you wanted to put a Raspberry Pi on the local network and just flood the backnet network with traffic, you easily could.
Right.
But it's if somebody knows that you have a grid of interconnected buildings and you can compromise one device and then propagate through there, it's that changes the risk reward of the attacker.
Yeah.
So but it's there's a certain obscurity to it right now, where it's kind of this is newer.
Well, yeah. So that does bring up some interesting cases. So yeah, if I know that this is an open network and I just plug in a Raspberry Pi into it, and then I can do whatever I want to on the network that way. And then if I know that VOLTTRON is a thing, I could put VOLTTRON on that Raspberry Pi, and then I don't even have to I don't even necessarily have to hack an existing VOLTTRON box, right? If I have access to the network, I could put my own VOLTTRON on a Raspberry Pi and then see what I could do with that. And that's
Well, that's certainly one. You know, that's a scenario all in of itself.
right.
I'm thinking more along the lines of me going to an Intel device that's running Linux on it that has a VOLTTRON platform running. I can restart that in single user mode and just I have root access to the machine now. And now I have whatever VPN credentials to connect up to whatever cloud platform. I now have I have all of the VOLTTRON configuration. You know, I'm not sure that maybe that's not really a VOLTTRON specific thing, but I think that, you know, that's kind of how VOLTTRON runs, or that's the environment that it runs on.
Right. There's what you can secure in VOLTTRON and then what you need to secure about the environment that VOLTTRON's running in. Brandon,
Exactly.
and
Yeah.
Brandon put together some platform hardening guidelines that are recommended for that, but I don't know, Chance and Patrick, I guess that seems like that's another threat profile or something that has different recommendations for how you deal with that sort of thing.
Yeah, I would agree with you, Jeremy. That what I'm hearing throughout this conversation is there's, you know, it's VOLTTRON, so there's overlap, and then there's some unique environments that would lead to a different threat profile. And when you do all of that, you've got complete control in all your possible deployments. That's what it's sounding like.
Yeah. Well, and then maybe that gets back to some of what Andrew was talking about is what other things can you put on, you know, whether it's in VOLTTRON or to the side or whatever, what other processes can you put in place to try and identify other types of threats?
Yeah. Yeah.
Well, I mean, I think we might see here. Oh, I am not muted. I think we might benefit from just enumerating some of these assumptions that you've made about PNNL's deployment, and detailing them a little bit, right? So, like, what is a secured network? What does that mean? How does that turn into a best practice?
Yeah.
I think that would be really helpful. And then we could dig into some of these maybe edge cases where that we know that that's not possible. So what are best practices to try to mitigate the risk in running in environments where that's not possible?
Okay. Yeah, and that's kind of something we talked about where, you know, you have this diagram and you could say, well, given, you know, these network security practices, these are the threats that you don't have to worry about. But, you know, if you don't have them, then you would. So, yeah, maybe some kind of explicit list like that.
I like that idea. And of course, we talked about those, but we never really explicitly documented them. So
yeah, exactly. I mean,
that value.
You documented them in the sense it says prevent using secure network policy.
Right.
But I think what we're saying is, you know, to move beyond this, I think it would be helpful to get a little more depth there.
Right. How does that change when we don't have that assumption?
And even just documenting what that assumption is. Like,
right.
I don't know what you mean by secure network policy. That might mean something different for PNNL than the University of Toledo. Is that, you know, port-based authentication? Is that, you know, MAC lockdown? Like, there's all kinds of different implementations there, and it would be nice to know what we think best practices are for our application.
Right. Yeah, and then I don't know, some kind of priority level or things like you know, this would be really good to do, and this is nice to have, and oh my God, if you don't do this, then you're opening yourself wide open or something like that, right? So, okay.
I just wanted to make one more comment, if I could. It kind of goes back to something Andrew said, and maybe something that you also said, Jeremy, with the Raspberry Pi. And I see the threat profile there, or the risk analysis, and it it's all about attack on the VOLTTRON platform itself. But what about the VOLTTRON platform performing the attacks?
So I would assume a comped box.
Yeah, so I know that you guys have mechanisms in place for registering agents and things like that, but you know, I could use the VOLTTRON box to then conduct denial of service on local networks. If I manage to compromise X number of VOLTTRON deployments, and then I just have something sleeping, and then you know, almost sort of like a botnet. You know, I'm compromising these VOLTTRON deployments to then conduct attacks.
Okay.
I would agree at the University of Toledo that's probably a plausible attack vector. We have a very secured network, but we also have a few machines that are, if somebody knew they were there, someone could literally just walk up to, and you know, of course, it already has permissions on the network, associated with its MAC address. So whether they were using VOLTTRON or not, they could walk up to a Raspberry Pi and do whatever they wanted to. And VOLTTRON communications aside. Incidentally, off topic, I don't know if it would be helpful at all. We do also have a network diagram of our network that shows something kind of similar to what you have in your use case here, though more to machine level, showing how our systems cross networks and such.
So basically a lower level of detail.
Right.
Yeah. And that's where there's a lot of avenues to take. If you're at a design stage or a review stage, you tend to want to stay at a bit of a higher level. If you're in the middle of development, or you've been through the design and review stage and you want to dig deeper, then you take a bit of a different approach as to what you're after in these diagrams. So that's an interesting way to look at what the options are.
Okay. Okay. Well, so what should be next steps for this working group? Would it be to start with defining what we mean by a secure network? Would that be the most helpful thing? And then maybe start sketching out the use case Andrew and Nigel and Dave were talking about?
We will definitely go through and document the kinds of assumptions that we've made in this document.
Okay. Okay, so does that, I want to make this this group useful for everyone. So is that would that be the highest impact thing to do next? And then after that's done, maybe we get back and try and dive into more detail with Andrew, the data collection use case, and then generate this same sort of diagram from that.
I mean, that would be great. Happy to participate.
Okay.
Yeah, that sounds good to me, Jeremy.
Okay, so we've got the holidays coming up. So when would be another good day to do this? Maybe the second week of January. Would that work for people?
That'd work for me.
Yeah, works for me.
Okay.
Same here.
Cool. Okay, and then we, anything we get produced before then, we'll send out to the working group, and we'll keep going. So my goal is at the end of January to have an understanding of the priorities of the community and be able to communicate that back to the sponsor. I think we already have a good start on that. So I think we should be in good shape there. And then these next few steps will be good. And the goal is to help us focus our development on where we get the most impact. And I think this should be good for that.
Can I ask a quick question, Jeremy?
Sure.
I saw on that you were talking about using Kerberos instead of SSH, and I'm just wondering how that was going to be implemented. Just quickly, if you have a couple minutes.
I think we're still looking at that. Craig, are you on the call still?
Yeah, I'm still here.
Do you have thoughts on the Kerberos?
Not at present.
Okay, so it's not something we're looking at. I don't think we've gone too far down that yet.
Okay, cool.
What is I was kind of curious about that too. One of the things we do is we use a Bastion host, so we don't actually allow direct login to any of the edge devices because obviously managing keys for those devices, which is what you're trying to mitigate here, becomes operational overhead that you don't want, and probably are going to leave behind some keys that shouldn't have access, etc. Is that adequate? Like if you used Kerberos on the Bastion host and then kept keys provisioned for the edge devices, or I'm just curious what your thought process there is.
So how are you managing yours right now? Could you talk about that again?
So essentially on each edge device, a provisioning server and a Bastion host are the two things that have keys on that edge device or have access. And so if you want to log in manually, not through the provisioning server, or not take an action on that box through a general, you have to do that going through a Bastion host.
Okay.
That was to prevent sort of having to deploy or manage the keys on the edge quite, A, not have 10 users keys.
Right.
And then B, not have to worry about revoking those keys, etc.
Okay.
We do all that at the Bastion host level.
So
I like that. I like the way that's set up. That seems to be that you are using least privilege principles for that, right?
Attempting to, yeah. And we've talked about how we do how we log commands run on the remote host or on the edge devices, etc. as well. But at least making everything go through the Bastion host means it's a lot easier to manage who has keys to that one device than who has keys to each edge device.
Yeah, exactly. So the Kerberos that's referenced here, that's for us accessing the VOLTTRON central box.
Okay.
And the data and the systems hosting the database.
Via SSH or other wise?
SSH for the VOLTTRON central box, and then communication to the database systems through with Crate or whatever.
So you would run like a HTTP proxy with Kerberos authentication in front of the database.
Is that how that's working, Craig? Craig, you're muted. Oh, he might have disappeared. He had someone working on his house. Yes, I believe that's how that's working.
Okay. Okay. Thank you.
Yep, no problem. All right. Well, cool. Appreciate everybody's time for calling in for this. Is there any other comments or next steps or something? Any questions people wanted to cover?
I'm sorry. I think I heard my voice mentioned in vain, but what was the question?
So how are we accessing the crate machines? That's with our
Oh,
PNNL.
the crate machines are only available from certain IP addresses. They're off of IP table firewalls.
And we use our PNNL account to access them.
Yeah. They aren't. We aren't using the enterprise
Okay.
version. So there's no login credentials, which is we have it partitioned off such that in order to access those machines, you have to SSH into the box, and port forward the web interface if you want to use that.
Okay. Yeah, we're just trying to nail down where Kerberos is actually being used in this system.
That definitely could be where it's being used.
Okay. All right.
Thanks.
Yep. Well, thanks everybody. If there's nothing else, then we'll get started on defining what network security means in the context of this, and then I'll have Ann send out another survey to set up the next meeting, and we'll go over the new use case.
This is Chance. I've got one parting comment, I guess, and that is I really appreciate the feedback and the input as to what you see that's helpful and not helpful. The not helpful is especially helpful. What's not helping you is especially going to help us to know that. So we're not claiming to come in with all the answers. We're claiming to come in with some stuff we've done that's working so far, and we want to make it better. So it really is appreciated that you guys are giving us feedback.
Thank you.
Yeah, definitely.
Yeah, thanks. Thanks, Chance. At SES, we really appreciate you and the guys at PNNL putting together this working group. So, yeah,
Well,
it's great.
We thank you too, and Patrick, thank you for putting all the detailed work into all this.
See everyone in the new year.
Yep. Have a good holidays.
Okay.
Yeah, you too. Thanks.
Bye.
Bye.